Dear students, today I am going to explain the shear force and bending moment diagrams. Most of the members which are carry the cylinders and loads are acting on the members are perpendicular to their longitudinal axis, are basically call it as a beams. And we know in that context most of the people are they are confusing about that what is the column and what is the beam. Generally beams are carries the loads which are perpendicular to their longitudinal axis, whereas the columns are loads are acting along the axis of the members. So beams are considered among the most important the structural elements, and beams are used to most of the supports of the floors of the buildings or deck of a bridge or the wing of an aircraft, and also the axle of most of the automobiles and boom of the crane, and even many of the bones are acting as beams. Now let us see that what are the different types of beams. So there is a simply supported beam, cantilever beam, overhanging beam, continuous beam and fixed beam. So the simply supported beam, so the beam at the two extreme ends are simply supported, on that the beam will be lying. And cantilever beam, in the cantilever beam one end is fixed and other end is free. So this type of beam is called as a cantilever beam. And overhanging beam, now you can see that here there is a one support and here there is another support, and behind the support some portion of the beam is lying, those beams are called as a overhanging beam. And coming to the continuous beam, it's more than one support, this one support, second, third, like that there is a number of supports are lying, the beams are carrying on the more than two supports are called as a continuous beam, and two ends are fixed, those beams are called as a fixed beam. So now coming to the types of loads, on the beams there is a varieties of loads are acting. Now let us see that the few types of loads, what are the loads. If the single load, this is supports, and the single the concentrated or point load is acting, so that is a point load or concentrate load, and here it is a UDL load, that UDL means uniformly distributed load. Here the load is uniformly distributed over the length of the beam, that is W for Newton per meter length. So those loads are called as a UDL load. And here uniformly varying load, now you can see that the load is varying, at one end is minimum load and other end is maximum load, it's a uniformly varying the load. Now here similarly in this category there is a trapezoidal loads also, at one end it's not minimum, some amount of the load is there, other end is some amount of the load is there, that variation is in the trapezoidal fashion the load will be carried out. Okay. Now let us we are going to draw the shear force and bending moment diagrams. Okay. So what is the, because of these applied loadings and beams develop the internal shear forces and bending moments that in general vary from point to point along the axis of the beam. So we should design the beams if you know that where the maximum shear force is acting and where the maximum bending moment is acting, then it's easy to design the structure of the beam. In order to properly design a beam, it is therefore becomes important to determine the maximum shear and bending moment in the beam, where it will be obtained the maximum shear and bending moment. Once if you know, then it's easy to design the beam structures. So the maximum value of the shear force and the bending moment can then be obtained directly from these graphs. Once if you draw the shear force and bending moment diagrams, then you can easy to know that, visualize where the maximum shear force is there and where the maximum bending moment is there. So the shear force diagram and bending moment diagram are often used by engineers to decide where to place reinforcement materials within the beam, or how to proportion the size of the beam at various points along its length. Okay. Once if you know that shear force and bending moments, then you can easy to know that where you can use the maximum load, where we want to use the other materials, that you can decide. The most of the civil engineers are before keeping the items or any loads, and first they should know that shear force and bending moments. Now you can see that what before going to draw the shear force and bending moments, we should know that sign convention. The sign convention is very important while drawing the shear force and bending moment diagrams. Now you can see that the bending moment is referred by the letter M and the shear force is the V. Okay. Now, the shear force is acting in clockwise direction. Okay. The shear force is acting in clockwise direction and bending moment in the hogging, that sagging movement this beam is bending like this, that is called it the sagging movement, and this sagging movement and clockwise the force are taken as a positive value, and hogging moment the beam will bend like this hogging moment, and the shear forces are in anti-clockwise direction, that you can take as a negative sign. Okay. That sign convention is very important. Remember the sign convention before going to draw the shear force and bending moment diagrams. Once again I am telling, so the sign convention for the shear force is clockwise is a positive, and sagging movement is a positive, and whereas in the hogging movement and anti-clockwise forces are taken as a negative sign. Now, let us see that the few examples of the shear force and bending moment diagrams. Now, let us first take the cantilever beam with the point load acting at free end. Okay. Now, see, this is the fixed end, this is the free end. At free end the load W is acting. Now, due to the W, what is the shear force acting along the length of the beam, that you are going to find out. Okay. Now, at point B, the force is acting in downward direction, that is in the clockwise direction. Clockwise is a positive sign. So, now it is a positive. What is the magnitude? That is equal to that value W. So, the shear force that is equal to plus W. And if we take any point in between from this load to this any point, any other load is there, there is no other load. So, the same load is acting entire beam up to the fixed end. So, that is a uniform, the shear force is acting entire length of the beam from the free end to the fixed end with the magnitude that the point load. What are the point load magnitude is there? With that load, this entire the force will be acting on the beam. So, that you can represent here this positive sign. You see, this is a plus shear force. Now, coming to the bending moment. Now, at point B, so what type of this is a hogging moment. It will create the hogging moment. Hogging moment you take as a negative sign. So, now we can find out the bending moment. How we can calculate the magnitude of the bending moment? That the force into perpendicular distance. Now, the force or load is, and at what point you want to calculate the bending moment? The perpendicular distance and load is gives the bending moment, and that is W into X, and the sign is the negative. Okay. So, now this entire where you got the maximum bending moment will get at fixed point. Okay. At free hand bending moment is 0 because the distance is 0, and at fixed hand the distance is maximum. So, maximum bending moment will be obtained. So, now this is the diagram of bending moment diagram for the cantilever beam. Next, we will see that instead of the single load we have the multiple loads. Now, you can say take the same cantilever beam and with 3 different loads. Now, in this what is the shear force and bending moment diagram, you can see that okay, because of these loads are acting in clockwise direction, this all are creating the positive shear force. Now, you can see that point D to point C, the same magnitude, that 800, and at point C it is added 500 newtons. So, 800 plus 500, 1300 it will go in this. Okay. And from year to year the same load will be there, the constant, and here again the 300 will be added to the previous value. Then it is a maximum, this all 3 we can add, that value is the maximum shear force at the fixed end. Okay. Now, coming to the bending moment, we can calculate the bending moment. At point D, the bending moment is 0, the distance is 0. So, now if we take any other points, you can calculate this force into the perpendicular distance, bending moment will be obtained. And if we take here, I want to know what is the bending moment. So, you can calculate 800 into this distance plus 500 into the distance, add together, that will gives the bending moment. But all these are in the negative value because this is the hogging moment. For hogging moment, take the negative sign. This is the one example. Okay. Now, let us see the another example of simply supported beam subjected to the point load at the center of the beam. Now, in this case, now you can calculate, see that the 2 supports also the load is acting, that is in vertical upward direction, and middle the load is acting vertical downward direction. So, this is the load shared by these 2 supports, that is if it is P, it is P by 2. Okay. Now, you can find out the shear force. Now, you can see that here the shear force is in the anti-clockwise direction, that is the negative value. From this point to this point, this magnitude is same, but it is in the negative sign. So, that is the value p by 2, and from here again it will be acting in clockwise direction. So, clockwise direction you take the positive value and this negative value. So, another p by 2 will come in positive value. So, that this portion is acting as a positive shear force. Okay. So, for simply supported beam, that point load is acting at the middle. So, this is the shear force diagram. Now, coming to the bending moment diagram. So, now from this point, because this is a simply supported beam, the bending moment beam, how it will be this, here sagging moment. Sagging moment is a positive. So, this bending moment diagram is a positive. Okay. And the magnitude is same, the formula, the load into perpendicular distance you can calculate, you can obtain the moment.